and let me share my screen. Yeah, so first of all, I would like to update the information about the workshop that we are just organizing. We after the term in June, we organize a face-to-face 3-day workshop, and you can see that the dates of the workshop are already known. It will be in June 14 to 16, Wednesday to Friday. And I already sent out an email to the students who who enrolled in this course. And so and I invite them to attend this workshop. So thank you, Mohammed, for your interest. And so now there are 4 students who are interested in. So I will wait, let's say, till tomorrow, and then I will send an email list to the local 4EU Plus office, and they will talk to you, or they will help you to arrange a trip to Prague. Okay. So now.
Yes, thank you.
So let me switch to my presentation. I hope that you can see my screen with the title page, Introduction to Machine Learning. That's the title of the 12th lesson of our course. Okay, so before I don't know whether you are familiar with the term of machine learning, but before I will provide you with the description, what is it? Let me start with some illustration example. Let's focus on the task of word sense disambiguation. And namely, let's focus on assigning the correct senses or correct sense of the word line in the following sentences. And let's consider these 6 senses. Oh, sorry. I'm sorry. The mouse is so rather sensitive. Yeah. So the senses that we consider are phone, formation, text, chord, product, and division, right? And here is a list of 7 sentences, and each sentence contains the word line. Okay? So, for example, the first sentence is, I've got Inspector Jackson on the line for you. Then outside, a line of customers waited to get in. Then he quoted a few lines from Shakespeare. And your task is to assign the correct sense of line in the following sentences. Right? So you can do it on your own, and here on the right, now you can read the senses that I've assigned. I would say that for some sentences, it's rather easy to recognize the correct sense. But for example, in the last sentence, this has been a very popular new line. I'm rather unsure what the line means, product or formation in this sentence. And the task of word sense disambiguation is important, for example, for machine translation, or every time we want to understand the semantics of document, of text. We and to understand it well, we should recognize the correct senses of the words. Uh, if you think about this task, what you actually did when you pair sentences or word occurrence with a sense, we can ask questions like, what knowledge do we use to assign the senses? What are the keys for the correct decision? Or which sentences are easy to recognize the correct sentence and which are the most difficult for you or for us. Yeah? So we look at this task from a human being perspective, and we keep in mind the future, or that we would like to teach computers to do this task, to automatically assign, recognize the correct senses. And we would like to learn computers or teach computers, to do word sense disambiguation using machine learning. And it's right time to say that machine learning deals with teaching computers to learn from data presented as examples. Right? So it means that we prepare examples, and then somehow, and I will explain what does it mean somehow in machine learning, somehow we teach computers to learn from the examples that we prepared. Right? So we, as human beings, we do word sense disambiguation easily, more or less, using the context in the sentence and our knowledge of the world. Right? And we want computers to master this task as well. Right? And based on the answers that you provided to the questions that I posed minutes ago, will you be able to implement the disambiguation procedure? Right. So in other words, write some, let's say, a rule-based procedure to pair word occurrences with correct senses. Right? And the question is how well we could code these rules. So both the knowledge of the context, the knowledge about the context in the sentence, and knowledge of the word. And question is how much errors would our procedure be making. So instead of creating rules, handwritten rules, let's focus on machine learning. Right? So let's prepare examples and guide computers to learn from examples. And that's exactly machine learning. Let's now to understand well what is the basic idea of machine learning. Let's focus on a non-technical view on machine learning, right? And let's imagine that instead of teaching computers to do word sense disambiguation, let's teach kids to do word sense disambiguation, and let's focus on the word line. And we are teachers. So what we can do? We can land an English dictionary in library. Here in the upper right corner, there is a screenshot of, right? There is a screenshot of a dictionary item for the word line. It comes from the Collins Colville dictionary, and here I just present you the first three senses listed in this dictionary. There are definitely more senses. published or described in the dictionary. This is just for the illustration, right? Then we can discuss with kids the meanings, the particular meanings of line that are listed in the dictionary. And we also can focus on the context of line in example sentences, right? What is a typical part of speech class preceding the word line and following the word line and something like that. Okay? And then to test the knowledge that the kids acquired in the class, we prepare a quiz or we prepare a test, right? And we can include the sentences that kids met in the dictionary, and also we can include the sentences that they haven't met in the dictionary. Right? So both sentences that they are familiar with and sentences that they have not seen in the dictionary. Yeah. And then the final step is to evaluate kids' answers, to simply count the number of sentences. It means the word, the line occurrences they classify correctly, recognize the sentences correctly and incorrectly. Question is whether will all the kids get the best grade, the A grade? And the answer is maybe and maybe not. Why? So maybe they don't understand all the sentences correctly. Maybe they missed some sentences in the dictionary, or they can see sentences with the word line that they haven't seen while they were training, and even more they can see in the test sentences with the sense of the word line, let's say, they haven't met in the dictionary. Right? So for example, we use dictionary that doesn't include the sense product, right? And suddenly in the test there is a sentence with this meaning, this sense, right? So that's the reason why the kids could not be for 100% successful. Right? Because in the dictionary, there is only sample of all possible sentences or all the sentences with the word line that are on the internet. It is just a sample, and it's a the way I just described you how we teach the kids or how we teach computers is statistical based. We don't work with the complete population. And for sure, we would like to train or teach kids to improve their quiz results. Right. In other words, how to get better grades. So first, we can present them more example sentences, so we can learn more English dictionaries, and so then the sample that we use for teaching is bigger. And then we can analyze in details the sentence context of the word line, right? So to focus on sentence specifics, the morphology characteristics, syntactic characteristics, and so on. So machine learning is teaching computers to learn from examples, and it's and I did not present you a non-technical view on machine learning just for curiosity, but we can see an analogy. And we teach computers to learn from examples in 5 basic steps. Right? The first one is to formulate the task, what we want to do. In our case, we assign the correct sense of the word line in a sentence. Then the second step is to get examples. Right? This set of examples is we call it so-called gold data. Gold data. And in our task, in the task of word sense disambiguation, we read sentence a sentence in some collection with the verse line, and we manually assign each occurrence with the correct sense. We call this process annotation, or manual annotation, or manual labeling. Then we split this collection, the collection of examples, into training subset and test subset. Then we learn, or then we learn. Then computers learn from training examples using machine learning methods, machine learning algorithms. So going back to the analogy with learning with teaching kids to recognize senses, we learn them how to read or how to understand sentences that are present in the dictionaries. And then we test the learned knowledge that we call model. We model language evidence. Then we test the models on test data. So again, here we can see the analogy with the quiz for kids. And the very last step is the evaluation, right? To measure number of errors or number of correctly classified the line occurrences. So 5 essential steps of machine learning approach. Here I provide you a formal definition of machine learning presented by Tom Mitchell in 1997. I don't want to be formal when presenting you what machine learning is about, but I think that it's useful, and it's useful to present you this definition. And this definition says a computer program, in other words, computer or machine, is set to learn from experience E. By experience, we mean the examples with respect to some class of task T. So we are addressing task T, and performance measure P. That's the way how we evaluate let's say the quality of a learning process. If its performance at tasks in T as measured by P improves with experience E. Right? So the more data we have, the better. In other words, the more data we have, the higher performance we expect, or the higher performance we observe in the learning process. And it is a statistical learning, so we don't work with all the examples that could be available. We have just some sample. So in other words, a machine learning problem is defined by a program, meaning computer program, learning from experience, examples E with respect to task T, while its success is being measured by the performance P, which would be improved at performing task T with experience. So which could be improved with the more examples we have at our disposal. We distinguish two classes of machine learning tasks, and one of them is so-called supervised machine learning. And it is a building or creating a model from examples for predicting an output for an input. So, for example, in the task of word sense disambiguation, an input is a sentence with a word, with the word line, and we predict its sense, right? So for an input, we predict an output. And it is a supervised machine learning because we as teachers or supervisors prepare examples. Right? I said that for the task of word sense disambiguation, an input is a sentence with the word line. But to approach it or to show computers how to learn from these examples using machine learning algorithms, we have to represent an input, or we have to represent real world objects in like sentences in this task, and we represent them using a vector. And again, I will explain in details in a minute. So representation or vector representation of real world objects. And based on the type of an output, we distinguish two machine learning tasks: classification and regression. If an output is a category or class, like in the task of word sense disambiguation, there are 7 senses, 7 classes, then we speak about classification, right? So one of the classification tasks is a spam email detection, and the goal is to train a model to identify which new incoming emails are spam and which are not. And in this plot, you can see that we represent an email using two attributes or characteristics: number of sentences, how many it is the number of sentences in the document in an email, that and the number of geographical names. Right? It is just for illustration, right? And these points represent examples that we have, and some of them are blue and some of them are red. Some of them belongs to the class non-spam, and some of them are not spams. So classification, the prediction is classification, and we classify real world objects represented as a vector into classes. And if an output value is a numerical one, then we speak about regression. For example, here in this plot, here I should say that these are the examples, the blue and red points, and they represent they represent real world objects. So they represent an emails, for example, emails in your inbox. Here in this plot, the blue points represent cars, and based on their weight, we represent their fuel consumption. Right? So the output value is the number of miles that a given car pass per gallon, and it is a numerical value. So that's the regression task. So classification into classes and prediction of real values. Here is a list of examples of supervised machine learning tasks. So as I already presented to the task of spam email detection. Right, so the goal is to identify which new incoming emails are spam and which are not. Then regression analysis. So the goal is to train a model to predict a numerical output based on the input characteristics. Right. So in our example, we predict vehicle fuel consumption based on its weight. But for sure, we can use other attributes to predict an output value, and it is related to the length of the vector using which we represent real-world objects. And another task of another supervised machine learning task is an image classification. And as a training data or goal data, we have a set of images with labels categories, right? For example, if we are supposed to recognize whether we see cat or dog in the image, right? So we have a set of images labeled with two categories, either cat or dog. Okay? And we train a model to accurately classify new images into two categories. So then the model classify images of animals as either cats or dogs. Sentiment analysis, given a golden set of examples. Here a set of labeled text data, positive or negative, whether positive or negative sentiment. Then we train a model to classify the sentiment of a new text data. And the task of authorship detection is to automatically classify a given text into one of several candidate authors, or to determine if a given text was written by a specific author. So it is in this list, there are 4 classification tasks: spam email detection, image classification, sentiment analysis, and authorship detection, and 1 regression task. And for each so in this task, we classify emails into 2 classes. In this classification of cats and dogs, again, we classify images into 2 classes. Here in the task of sentiment analysis, we can set up the sentiment classes, positive, negative, and neutral. So then we classify text into 3 classes. And And in this task of authorship detection, we can handle it as a multi-class classification. So then where the number of authors or possible authors of a given text could be more than 2, or we can reformulate this task as a binary one, saying or predicting whether a text was written by one specific author or not. And and this classification task is often used in literary studies, forensic linguistics, and plagiarism detection. Okay, so here is a scheme of supervised machine learning, and we represent it as a triangle with 3 nodes. Here is a node representing real-world objects, text, images, cars, whatever, flowers, whatever. Then here there is an arrow going from real-world objects to vectors. So we to automatically do some task, we have to represent real-world objects, right? So we represent them as vectors, and this node corresponds to target values. What we, in other words, output, what we are predicting. If when we prepare examples or the gold data, when we do manual labeling of emails, manual labeling of images, manual labeling of novels, we do so-called true prediction, right? So we manually classify the real-world objects. But machine learning focus on this error, on the relationship between inputs and outputs. And why we do machine learning? Because we don't know so-called true target function. We don't know what is the proper relationship between emails and spams and not spams. So since we don't know this true target function, we have to approximate it. Right? And we approximate it using machine learning algorithms. Here is the clear visualization of gold data of examples that are crucial for supervised machine learning. And based on using this gold data and machine learning methods, we got a computer program. We call it predictor or classifier that performs a given task. So in other words, the main objective of machine learning is to build models by interpreting data. So based on these examples, we built model using machine learning to interpret data. So by this data representation, the data representation it's a way how we feed the computers with real world objects. So data representation or feeding the computers with examples, and each example is represented by one vector. Okay, so now I hope that you have at least, let's say, raw idea what machine learning is about. So learning from examples, we have to prepare examples, and then using mathematical methods, we teach computers to learn from examples. And to do classification over real world objects, we have to represent real world objects using vectors. Now, let me describe you machine learning in a broader context, and namely in the context of artificial intelligence. These two terms, machine learning and artificial intelligence, AI, they are related but distinct concepts. So let me mention some key differences between the two. So as you can see in this visualization, machine learning is a subset of artificial intelligence. And artificial intelligence refers to the context of creating machines or systems or computers that can perform tasks that would typically require human intelligence, such as reasoning or problem solving and decision making. And machine learning is a data-driven approach where models are trained on data to learn patterns and make predictions or decisions. Right? So we are interpreting data, so we are searching for patterns in the data. And the focus of machine learning is on developing algorithms or methods or techniques that can automatically learn from data. On the artificial intelligence, on the other hand, encompasses a wider range of approaches, including rule-based systems, expert-based systems, symbolic reasoning, knowledge representation, and other techniques beyond data-driven learning. Right? So machine learning is a data-driven approach. Sorry, is a subset of artificial intelligence. Machine learning is primarily concerned with building models, so using algorithms, learning knowledge hidden in the data. So we focus on machine learning, focus on building models and algorithms that can perform specific tasks such as image recognition, spam detection, speech recognition, recommendation systems. And it is a narrower field that focuses on developing specialized models for specific tasks. Artificial intelligence has a broader scope and aims to build systems that can exhibit general intelligence and perform a wide range of tasks across different domains. Machine learning models can achieve high accuracy and perform complex tasks, but their approach to learning and decision making is often different from human intelligence. Artificial intelligence focus on developing systems that can exhibit human-like intelligence, including tasks that require some perception, understanding, reasoning, and creativity. Machine learning techniques are being used in practical applications, and artificial intelligence systems includes areas such as robotics, autonomous vehicles, virtual assistants, intelligent systems in healthcare, finance, and other domains. So artificial intelligence is an interdisciplinary field that combines branches of computer science, statistics, mathematics, statistics, including machine learning, natural language processing, robotics, computer vision, and so on. So that's the context of machine learning with respect to artificial intelligence. I should also mention or highlight deep learning and traditional learning. So this scheme here is we already know that machine learning is a subset of artificial intelligence. And in machine learning, we distinguish two different approaches to building models, namely so-called traditional learning and deep learning. And so traditional learning methods, they typically require handcrafted feature engineering. Going back to data representation here, right? So we represent real-world objects using vectors. It means that we have to select some attributes or features using which we describe real-world objects. Right? So, for example, in the example of spam detection, I mentioned two possible features. One of them is the number of sentences in the document, and the number of geographical names in the document. Right. So then, focusing only on these two features, the real-world objects will be represented by the vectors of the length 2. Okay. So, and it's typical for traditional machine learning that we so it's typical for traditional machine learning that we manually design features that we use to describe real-world objects. We speak about so-called feature engineering, right? So where domain experts manually design and select relevant features from the input data. And in contrast, neural networks learn features automatically from the data, and it allows to capture complex patterns and representations of the data. Neural networks, again, I don't want to dive into technical details, but to understand what's going on in today when people speak about some really about milestone in artificial intelligence, or I would still say milestone in machine learning. I have to give you at least very short description of deep learning and neural networks. Deep learning uses deep neural networks to model relationships in data. Right? So here is an example of a neural network. Here in blue, we read the input. Here we read the output, and here are two layers, which is typical for neural networks. Right? Because neural network consists of multiple layers of interconnected nodes, and or neurons. Again, means thinking about analogy how our brains work, and this this neural network process input data and produce output data. And deep learning uses deep neural networks. So one of the algorithms, machine learning algorithms, are deep neural networks. Neural networks often require large amount of training data, training examples to achieve good performance. Traditional machine learning methods may require less data, as they rely on handcrafted features. So here you can see the representation, data representation. In this picture, this is the illustration, or this is the visualization of traditional machine learning method. So here you can see an expert designing features, designing the data representation of real-world objects. There is some machine learning algorithm. And while in deep learning, in this step, it includes both feature extraction and classification. Right? And if you recall the Titanic data set that we mentioned at the very beginning of the course, each passenger is described with the attributes like class, name, sex, age, number of siblings and spouses, number of parents and children, and so on. Right? And here is a target value or target attribute with two possible values. Right? So this is an example of manually designed features using which we describe passengers on board Titanic. The traditional machine learning methods often provide an interpretable models, where the learned parameters can be easily understood and analyzed. And this is very important for in certain domains such as healthcare or finance, where interpretability of the model is crucial for decision making, right? So one of the traditional machine learning algorithms is a so-called decision tree learning algorithm. And the model that we train from the examples has a form of decision tree. And how to read this tree? So there is a root node, and there are internal nodes, and there are leaf nodes, right? And each internal node is represented by a decision or question on a single feature. This model that you can see here is a result of training decision tree modeler to predict whether a passenger on board Titanic will survive or not. So the very first question or decision trained is concerns the sex, the sex of a passenger. If it is a male, then the decision on the age follows, namely whether the passenger is older than 14. And if yes, then the prediction is that such passenger will not survive. And here, going back to the root node, if the sex value, the sex feature, or its value is female, it means that it's not male. Then we ask the question, or the system asks the question on the P class, and if it is three, if her or his class is three, then we ask what was his or her fare, and if it was higher than 23, then the system will predict that a given procedure will not survive. Right? So here I'm rather surprised. Where so it means that if the fare was lower than 23, then the chance to survive was higher. But the let's take it as an illustration of a traditional machine learning model in the form of decision tree, and you can see that the interpretability of a of this model is really high, right? We can see what's going on in the system, right? On the on the other hand, these neural networks are typically considered as a block boxes. As their internal working is very complex and difficult to interpret, and it make it challenging to understand how they arrive at their precision. Um, Traditional machine learning methods typically have lower inference time compared to neural networks, as they often have simpler and fewer computations. Right? The training of training of deep learning models is very time consuming, and so it means that that the neural networks have higher inference times due to their complex architecture. Okay, so to conclude this part, the description of differences between traditional and deep learning methods, we can say that they have different strengths and weaknesses for sure, and the choice between them depends on the specific requirements and constraints of the task at hand. So traditional machine learning methods may be preferred when interpretability, small data sets, or faster inference times are important, while neural networks may excel in tasks that require complex representations, large data sets, and high accuracy. So when addressing a task, you have to carefully think about the methods you will use. Since the deep learning methods require really big number of examples, so if you have a low number of or a small number of examples, you should prefer traditional machine learning methods. But at the same time, I should say that we will see what will happen in the future, the close future. I hope that you already met the chatbot called ChatGPT, and you can experiment with it, and I would say that you will be impressed. And it is actually an example of machine learning task. It is in concerns of building language models, and the task is to predict a next word based on the preceding words. That's the machine learning task. Okay, and so this is the relation of artificial intelligence, machine learning, and deep learning. And I also want to stop by the field of natural language processing. You already met the systems of UDPipe and NameTag. UDPipe is a pipeline of linguistic processing text, starting with sentence segmentation, tokenization, then part of speech tagging and syntactic tagging. And NameTag is a system to recognize and detect name entities in text. And both procedures are machine learning based, So we first had to prepare examples to train these models, right? And there are these two systems are the machine learning systems of natural language processing. Let me characterize natural language processing as a part of the field of computational linguistics. It is a multidisciplinary study of human language from computational perspective, right? So, and computational, and it has two parts. It has two main components of it: linguistics and computer science. And this component is a natural language modeling, right? So, sorry, natural language processing. In other words, modeling language use. Natural language processing deals with computer and human interaction in both written and spoken natural language. So we work with the forms, with both written and spoken forms. And natural language processing uses corpora of text or speeches, sometimes enriched with linguistic information. So in other words, it uses annotated corpora, and the annotated corpora serve as gold data for training of procedures or systems of natural language processing. And in comparison to mathematics and physics, computational linguistics is still young lady, I can say. Its origins date back to 1950s, when the very first experiments of machine translation were performed. And machine translation means translation from one language to another using a computer. And the results of those rule-based systems were not as correct as expected. So to move it forward, Professor Jelinek and his team at IBM approached this problem using or approach this problem from a different perspective. At the end of the 90s, or at the very beginning of the 90s, they introduced a statistical approach, and it was so different that reviewers called it simply beyond the scope of computational linguistics at the time. And time has shown how wrong they were, and natural how wrong they were, and what more, it has proved that the interaction among scientists from both humanities and natural sciences is more than necessary. And this statistical revolution in 1990, sorry, in 1990s caused the great development of corpora, collection of text, and the use of machine learning. Very crucial moment. Okay, so this is the story of machine learning. And now let me focus on the final step, the fifth essential step I mentioned. And this is the evaluation of machine learning systems. And let's focus on class of binary on the task of binary classification, like detecting spams in your email inbox, or task of classification of Titanic's survivors. And let's use so-called confusion matrix to evaluate binary classifiers. We use a test set to evaluate binary classifier. So it means, and this test set is a subset of gold data. So it means that for each example in test data, we know its true classification. And that's the information that we read in the rows of the table. In binary classification, we classify examples in two classes, and we call them positive or negative. So positive, here the positive stands for the examples that are classified as a positive one. So it means Titanic survivors or spams. And negative here stands for negative examples. So it means it stands for example, for passengers who didn't survive, or emails that are not spams. That's what we read. That's what we read here in the rows. In the columns, we read the predictions made by a binary classifier, right? So predicted class, true class, and predicted class. And the system predicts or classify examples into positive classes and negative classes. And these cells in the table are the numbers of examples with specific properties. So in this column, we read, in this column, we read the number of examples classified as positive ones using the system, positives. But here, and using true and false, we distinguish whether the classification was correct or incorrect. Right? So here, true positives is the number of true positive examples correctly classified by classifier as positive one. The same for negative examples. Here we read the number of true negative examples that are correctly classified as negative using the binary classifier. So this is a confusion matrix for binary classification. Right? So truths are examples correctly classified. That's what we read here on the diagonal. And off the diagonal, we read the errors, or we read the number of errors that classifier did or made. And yeah. And based on this confusion matrix, a number of performance measures is formulated. And one of them is so-called sensitivity or recall. And it is a measure that quantifies an ability of a classifier to correctly identify positive examples. In other words, to correctly identify spams, to correctly classify Titanic survivors, patients with the disease, and so on. And here is I would say, very nice visualization of the positives. So here is a set of predicted positives. In other words, a set of emails that that classifier classified as spams. And here is the set of true positives. So here in the interjection of these two sets, these are true positives, right? So correctly classified true positives. And here we read the false negatives and false positives. Right? And the sensitivity or recall is the ratio of true positives. So it means the interjection of these two sets versus the true positives plus false negatives, right? So ability to correctly identify positive examples. And now let me present you the last homework number 6, and we call it subject labeling of an EU regulation. It is a classification task, and the goal of this task is to identify which word in a text is or is not subject. Right? So let's read document since the very beginning to end, and for each word we say whether it is a subject or not. Subject in subject and predicate. So we speak about subjects with respect to syntactic properties of sentences and words and dependencies between words. So we are working with the regulation of the European Parliament and of the Council of 16 December 2020 on a general regime of conditionality for the projection of the Union budget. Right? So here is the list of versions of this document, and in this document, let's open the English version. And you can see that this document has a preamble, and preamble consists of 29 items, and you will be doing annotation task on this part, on this 29 items. And if you go to our web page, and there is a tab called data, and if you open it, here is the link to preamble. And on this page, the annotation task, it means your homework, is described in details. We already did this task last year with the students attending our course last year, and the students were annotated 4 versions: Czech, English, French, and Polish, and we published this data. Each document was annotated by 2 students, so we can easily measure their agreement, so-called inter-annotator agreement, and we publish this preamble of these 4 versions, and with the annotations made by the students. Right? And so here is the description of the collection that we publish, and it's open to anyone in the at the Linda Claria repository. Right? And here is the detailed description of your homework of the annotation task. Right? So the task is to annotate subjects in the sentences of the preamble of the EU regulation in one of the 2 languages, English and Italian. And our motivation to organize this task is twofold. So first of all, we want to evaluate UDPipe system on manually annotated data. UDPipe includes a syntactic parser. So it specifies what is subject, what is predicate, and so on. So we want to have data to have more data, let's say, to evaluate it. And it's actually the motivation. It is our motivation, or our motivation, that is useful to us. But for you, we want you to get experience with readability of legal text. In the course, we have not presented you data from legal domain. From the legal domain, we presented you Andre Amazon's correspondence, migrant stories, and legal domain is definitely very different. And typically, legal documents are very difficult to read, and we would like you to have experience with readability of legal text. And so I hope that you've got an email with the instructions on annotation task, and I've got an email from Irka Mirovsky. And this email includes the instructions what to do, right? So these are instructions for the 6th homework assignment in our course. The task is to annotate subjects in the sentences of the preamble. The text is available in 2 languages, and you are supposed to annotate only one of them. So you can select the language you prefer. Then you will be using the annotation tool BRAT, and I will illustrate you how it works. It is a web application, so it means that you can run it easily from your browser. And then there are links to BRAT for Italian version and in English version. So I prefer the English version. So let me open this link, and then I should log in to the system, and let me, what was it? Yeah, here are the login name and password. What is the password? Oh, capitalized B. I'm sorry. You have different login names and passwords. Yeah. So so now you can see that I already logged into the BRAT. And what we can see here, so here are the login button, and here on the left, if I click on the collection, you can see that in this folder there is an English version, and if I go up, there is a folder for Italian version, and you can see the version Italian version. So now let get me back to the English version. Yeah. I've already started with the annotation, and so we logged into the BRAT editor using the credentials sent via email, and then what we will be doing, we should read carefully the preamble and identify subjects in each sentence. And I hope that you at least remember your experience with doing sentence diagrams at your secondary school. Um, but here we follow the Universal Dependencies Annotation Guidelines. Sylvia presented you this universal framework for syntactic annotation of text in different languages, and it works. It works with Word as a basic unit, right? So it means that the subject is exactly one word in our annotation task. Typically, it is a noun, pronoun, or relative pronoun, and you can meet or you can read the coordination of subjects in the text. So then mark all subjects standing in a coordinated construction separately. Let me illustrate it. So let's start with the first sentence and let's read it. The Union is founded on the values of respect for human dignity, freedom, democracy, equality, and so on. Right? So union is a subject. Right? According to the Universal Dependency Framework, it is a subject that we label in the sentence. In the sentence 2, as recalled by Article 2 TEU, those values are common to the member states. So values is a subject to the member states in a society in which pluralism, non-discrimination, tolerance, justice, solidarity, and equality between women and men prevail. So here is the coordination of subjects, and we mark them separately. And let's go to the sentence 8. And it says, it requires in particular that the principle. So it is a subject. So let me double click on it and then push the button with OK. And now you can see that it is labeled as a subject. Yeah. It requires the principles of implicating. The accession criteria established by are the essential. So accession criteria is the subject. Okay. And if you make an error, and if you, for example, if you label European as a subject, you can remove your annotation, double click on subject, and here in this window you can delete it this way and confirm it. Right. So this is the annotation task, and yeah, so you are supposed to annotate either English or Italian version, and please do it by next Tuesday, by May 13. It is not next Tuesday, it is what is May? Oh, the 13th of May. I would say Friday next week. Actually, yeah, Saturday 13. So you have more than 1 week to finish this task. Yeah, they're useful links from Syria. So are there any questions on this task, on this homework?
Thank you so much. No, just I want to make sure that the deadline would be May 13th, right?
May 13th, yes.
Okay, great. Thank you.
Thank you.
Sorry, can I ask a question on our other project of the final one, the final presentation?
Sure, that's probably more for me.
Yes, I was asking about the deadline for our presentation because I feel like it's stated like the last year's deadline on the website. It's May 3rd on the website.
No, it was that's the real deadline, because we want you to present. We want to show selective presentations in the last 2 lessons. And since at the beginning of the term you were pretty many, we just wanted not to have it live, but have the recordings first and only show interesting pieces of it or selected presentations.
Okay.
Yeah, and therefore we set this deadline.
Okay, got it.
Perfect.
Thank you.
No problem.
So let me get back to my presentation, and I want to illustrate you the evaluation of agreement between students, right? So as I already said, we did this task for Czech, Polish, and French version, and each version was labeled by 2 students. And here you can see the number of words in each language version. Yeah, and so for illustration, how to measure inter-annotator agreement, I will illustrate you for all the language versions we annotated. And so for Czech version, we use the confusion matrix that you already know. And so we have 2 students, we call them annotators, A1 and A2. Yeah. And we do binary classification. So for each word we say, okay, it is a positive example, it means it is a subject, or we say, no, this is not subject. So classification, positive, negative, positive, negative. And how to read the confusion matrix. For classification of predictors, we read through values, through prediction in rows, and predicted values in columns. Here we read the annotations by first student in rows and the annotations by the second students in the columns. And we can see, and on the diagonal, we can read the number of words correctly annotated, or not correctly, but annotated identically by 2 students, right? So 113 words were detected as subjects by both A1 and A2 students, right? And the other words, more than 2,000 words, were not labeled as the subjects by both A1 and A2 students. And differences, we read the differences of diagonal, right? So annotator A1 labeled 3 words as subject, but annotator A2 did not, right? And here 33 words were annotated as subject by A1, but not by A2. So the total sum of these 4 numbers corresponds to the number of words in Czech version. That's the reason why I presented you here the number of words in the language versions. And the sensitivity that I mentioned you a minute ago is so-called recall, and it is 77%, right? It is or 0.77. So the agreement is rather high. And here is the visualization of the same annotations and differences. So there are more measures defined over confusion matrix, like precision. And if we want to combine precision and recall into one measure, we use so-called F1 measure, and it is a 0.85. So it's rather high when we consider that 1 is a maximum. We did the same computation for Polish and French version, and we can see that the higher inter-annotator agreement is for Czech, then for Polish, and the lowest one was for French students. And we will see which version you will annotate. Definitely, we compare your annotations, and we also provide you with this numerical evaluation. And as I already said, our motivation is to have another data to evaluate an automatic procedure UD pipe. The UD pipe is a procedure that performs a complex syntactic analysis. It doesn't focus on subjects only. It does a complete syntactic analysis. So what we did, we process each language version with the UD pipe tool, and we measure its performance. We measure its performance, and we compare it against all the annotators, right? So we can see that the agreement, let's say the agreement measured by F1 score between automatic procedure UD pipe and Czech student A1 is 81%, with student A2 79%. The highest agreement is between UD pipe and Polish student or student who annotated the Polish version. So that's it's really very interesting, and so we will see what numbers we will get from your homework. Okay, so that's it for today. If you have any questions or comments, I will be happy to answer them. If not, I wish you good luck with your 6th homework, and for sure don't hesitate to contact me if you have some troubles with the Brat editor, but I don't expect. It's very nice tool, and I think that you will like it in the end.
Thank you so much. I'm sorry, can I ask a question about the final presentation from Sylvia, I think?
Sure.
Yeah, thank you. The deadline is tomorrow night, right? To make sure.
Yeah.
Okay, thank you. Can't we extend the deadline for 1 or 2 days so that we can more focus on the quality of the work? Sorry, I know it's been a long
I understand.
time.
Fully. I need to have something to show you the next week, and given that the presentations should be 10 to 20 minutes long, I would be grateful for something like 5-6 presentations of those of you who still attend the lessons live. So that I would be very pleased if I had it by, let's say, Tuesday night, so that I have Wednesday for having a look at those and preparing questions or whatever. So the critical date is next Tuesday. So Monday night. Sorry.
Okay, thank you. So the next Monday night would be the final deadline, right?
Yeah, and I will be very pleased if it's earlier, and I can have a look at that before.
Okay, thank you so much.
No problem.
Okay, so goodbye. I'll see you
Bye
next
bye.
week.
Thank
Goodbye.
you.
Thank you.
Goodbye.